Chapter 7, Lesson 3 is solving word problems. So again, since it's solving word problems, that means this is the last lesson of the chapter, which incorporates the previous lessons. So I'll write down in the board again, the formulas that we need is distance is equal to speed times time. From there, we should have speed is equal to distance divided by time, and time is equal to distance divided by speed. Okay, and we also found average speed is equal to total distance over total time. Okay. So, just as a reminder, speed is just the same as a rate, and it's again best for the kids to write down the givens or the information given in the problem, as well as whatever formula they will decide to use. Okay, so our questions will come from two pages, pages 24 and page 29. Okay, so starting with page 24, it says, this is problem number 3. Mr. Omar took 4 hours to drive from town A to town B at an average speed of 50 kilometers per hour. Okay, so the book has a drawing and it has blanks that we're supposed to fill in. So we will go ahead and do that. So the speed is 50 kilometers per hour. Okay, and then it says 4 hours. So time is 4 hours. Okay, so for these word problems, again, it's ideal that as we read and there's information, we want to write it down right away and not read the whole problem, because then that means you just have to reread it again. Okay, so this is from A to B. Okay. So then it says, from A to B, yeah. On his return journey from town B to A, so going this way, that's his speed. Going back, it says he traveled at an average speed of 80 kilometers per hour. So that means speed is 80 kilometers per hour. Okay, so then the question is, how long did Mr. Omar take on the return journey? So this is what we're looking for, the time. Okay, so clearly, if we want to find the time, we need the distance here, because the formula says you need a distance and you need a speed. The speed is given. But we're not given the distance, which means the distance here can be found using this distance formula, because the distance from A to B is just the same as the distance from B to A. Okay, so which means first step is we need to find distance is equal to speed times time. Okay, or rate times time. So that means here the speed is 50 times 4, which gives us 200 kilometers. Okay, so the trip going from A to B is 200 kilometers, which means returning from B to A, it's also the same distance. So that means if I need to find the time, that would be the distance divided by the speed. Okay, which means this is distance is 200 divided by 80. Okay, so again, since this problem actually does not have a calculator. So, but we know that this and this cancels. So it's easier to go ahead and solve that out, and we should get 2.5. So that means this is 2.5 hours. Okay, now the book uses this strategy, this triangle bit. Okay, now there are many schools that utilize this. I don't suggest that you do, because the formulas should suffice. The problem with this triangle is over the long run, they'll interchange the letters that goes inside the triangle. So it's not as helpful for long-term purpose. For short-term purpose, yes, it might be fast, but we're learning for the future, not just for the now. So again, I prefer that we all just stick to the formulas because they're not very hard to remember anyway. Continuing on to page 29, problem 5 says, Melissa and Shane started jogging at a constant speed from their house in opposite directions. Okay, so this is the house. One goes to the left and the other one goes to the right. So where you put the arrows don't matter, but in this case, they gave a drawing, so we follow it. But if there was no drawing, then it's okay to put whoever goes on which direction. Okay, so here in their drawing, this is Melissa. Okay, and this is Shane. Okay, so then it says, Melissa jogged at a speed of 100 meters per minute. Okay, so that means I'll put it here. Speed is 100 meters per minute. Okay, at the end of 20 minutes, they were 3,800 meters apart. Okay, so that means the time that they both traveled must be the same. So that means this is 20 minutes, and so did Shane. Time is 20 minutes. Okay, so I'm going to read that again. It says, Melissa and Shane started jogging at a constant speed from their house in opposite directions. Melissa jogged at a speed of 100 meters per minute. At the end of 20 minutes, meaning both ran for 20 minutes, they were 3,800 meters apart. So the question is, find Shane's jogging speed. So we're looking for the speed. Okay. So in order for us to do that, that means that we need this formula. Okay, which means we need to figure out how far Shane jogged. Okay, but to do that, we need to first figure out how far Melissa jogged so that we can take it away from 3,800. So we'll start with Melissa. Okay, so Melissa, distance is equal to speed times time. The speed is 100, the time is 20, which means that's 2 with 3 zeros. Okay, so Melissa ran 2,000 meters. Okay, which means if Shane and Melissa ran a total of 3,800 meters, because that's how far they were apart after 20 minutes, then that means the distance of Shane must be 3,800 minus 2,000, which means that's 1,800 meters. Okay, but we are given the time, which means if we want to look for the speed formula is distance divided by the time. So the distance we just found is 1,800. The time is the same, 20 minutes. Okay, so again, this problem does not have a calculator. So we need to use strategies that we've learned in the past. So that means the zeros can be cancelled, and 18 divided by 2 is 9 with 1 0. So which means the speed of Shane must be 90 meters per minute. Okay, so again, parents, these are word problems, but they're a lot more manageable than the word problems from before, because there's now a formula. If we follow the formulas, if we write down the given, then it's not so stressful. So we just need to keep doing that when we do these problems. That concludes lesson 3 of chapter 7, which concludes the chapter. See you in the next chapter.